The goal of AESQ is to improve the quality performance of the external supply chain by deploying world-class industry standards and guidance materials. AS13100 represents a major milestone in this journey. The executive overview will outline the structure and the content of the standard, and we will hear from some of the business leaders and subject matter experts that helped to create it.
Look up. At this very moment, thousands of planes are carrying millions of passengers all over the world to reunite families, to further business, to explore new places. These numbers are expected to double over the next 20 years. As passengers continue to put their trust in air travel, safety remains our primary concern. Customers expect zero defects with every product, every time. It's up to the manufacturers and suppliers to deliver. With an increasing level of supplier-made engine content and a large number of common suppliers between engine manufacturers, improving quality, cost, and delivery is a key challenge facing the aerospace industry. In addition to these challenges, COVID-19 changed the face of air travel, and new challenges emerged within the industry. With demand down, customers are focused on quality. Higher quality demands put the supply chain at risk.
If we reflect on quality and the essence of quality in our industry, you can think about why is that important. One side of it is, without good quality, it would be a lot of waste and it costs too much. It's a fundamental portion of the cost structure in our business. Better quality makes better predictability and also less waste. On the other side of quality, of course, when we talk about quality, is end of the day is security and safety of our people. Myself, all the close ones, and everyone else in the world, you want to know that you can land when you go on it.
As aero engine community, we have experienced more product recalls in recent years than expected, with significant economical impact on the airlines. Certainly, time to market and new technologies are a challenge. Nevertheless, it's our mission. We have to raise the bar of quality throughout the aero engine supply chain.
When I'm asked about the importance of quality in our supply chain, well, for me, it's quite obvious. In manufacturing an engine, we buy more than 70% of those components from our supply chain. And unfortunately, the majority of our quality issues emanate from the supply chain also. When I think about the role that our suppliers play, let's talk about the job that the engine does. And safety has to be number one. Aviation, through the role of our airworthiness authorities and the role of the industry continually upping the game on quality, has led to an incredibly good safety record across all of aviation. And it's our job to maintain that in everything that we do. So think about these aspects: safety, reliability, cost, and delivery, and the impact that quality has on those in your business.
To achieve quality, there are few main activities. First is robustness. The second is early detection, is very key also, and collaboration and transparency between all the key supply chain actors.
Expectations are high. Quality in our industry is not negotiable. Unfortunately, airplane crashes can cause high fatalities. Therefore, such events generate high public attention and undermine our credibility. Due to the production ramp-up in the past and hopefully again in the near future, the level of quality and safety has to ramp up again. The flying public, you and me, we will never accept a higher number of accidents. The industry has reached a very high level of safety. Statistical data tells us flying is much safer than any other form of transportation.
Although quality impacts the business of both customers and suppliers, unfortunately, they're not always on the same page. Let's look at how customers used to perceive suppliers in the past. They were seen as reactive, focusing on inspection to sort good from bad. There was non-compliance to customer requirements. There were limited applications of process control and low maturity of defect prevention and quality planning processes. Finally, there was little continuous improvement activity. On the other hand, suppliers had their own negative perceptions of their customers. Each customer independently set complex requirements. High levels of external audits brought inconsistent interpretations. There was no common language for quality. And finally, there were high levels of customer control and intervention. One key ingredient was missing between aerospace customers and suppliers: collaboration.
The supplier's role in our industry is first to none. I mean, we are all suppliers to one level of system. So I think when we talk about suppliers' importance, we need to remember that most of us always have customers. When you think about it that way, you need to make sure the whole chain works. So when we talk about supplier performance and the importance to have the same standards again, the same way of working and making sure that we talk about quality the same way, that's the way we can get the whole chain to work.
There's a greater need than ever for suppliers and customers to come together to standardize requirements, create a common language for quality, and, most importantly, continue to foster aviation safety. One example of collaboration in the aero industry has been the formation of the AESQ.
AESQ stands for Aerospace Engine Supplier Quality Strategy Group. Our vision is to establish, deploy, and maintain a common set of quality requirements that enable the global aero engine supply chain to be truly competitive through lean, capable processes, and a culture of continuous improvement. AESQ now includes 10 corporate members, including GE Aviation, GKN Aerospace, Honeywell, Howmet Aerospace, IHI, MTU Aero Engines, PCC Structural, Pratt & Whitney, Rolls-Royce, and Safran. Collectively, we are driving a zero-defect culture throughout the aero engine supply chain, and the goal of improving quality, safety, delivery, and cost through more reliable quality performance. We have adopted these 6 guiding principles to accelerate our journey. Simplify and standardize supplier requirements. Build on existing industry standards that are simple, prescriptive, and auditable. Create a common language for quality. Promote standardized third-party training. Create standards that are easy to adopt within existing processes and systems, and deliver results rapidly through focused activities.
The AESQ relies on collaboration between customers that are also competitors, but also with the suppliers. We recognise that if we are going to come up with a simple set of standards that are easy to implement and drive real improvement, we need input from a range of different voices. All the key stakeholders that are involved in creating the standard, deploying the standard, and actually using the standard. The AESQ uses practitioners and subject matter experts from all of its member companies to help define, shape, and improve the standards that we are writing.
One of the goals of the Aerospace Engine Supplier Quality Strategy Group was to simplify how the aerospace industry handles requirements. Currently, the industry flows requirements down, eventually reaching the aero engine supply chain. It begins with the regulator, customer, and industry requirements, including NADCAP, IAQG, and ISO. Those flow down to the aero engine manufacturers, Rolls-Royce, GE, Pratt & Whitney, and Safran. Each manufacturer takes those requirements and passes them down to the supply chain with their own terminology, processes, and specifications. The AESQ wants to simplify this, using quality management requirements that will be found in a new standard, AS13100.
If we don't bring the suppliers and customers together, we will have this slight different coming across all the industry. And it sounds maybe not much if you're on the top, but if you think yourself further down in the supply chain, there will drive a lot of different variants and different ways of doing things. And different ways of doing things drives 2 things: a lot of waste and cost further down, but it also drives risk to quality again. Because when you're trying to do the best and you have all these different small variants, of requirements, it gives a higher risk that you do something wrong for someone.
Although there's already an aerospace standard called AS13100, the engine manufacturers have had to put supplemental requirements around this because they're expected to flow down the requirements from their regulator, the customer, and their own business. Because of the criticality of the engine and the potential consequence of any non-conformance, many of the requirements are far more stringent than you would get on any other commodity on the aircraft. The purpose of AS13100 is to take these supplemental requirements and build it into a single standard.
First benefit is a simplification of the relationship with our suppliers, thanks to a unit set of requirements, meaning less audits. Second benefit is bringing a set of best practice for better and earlier eradication of defects such as APQP, PPAP, AD, and human factor. Quality is the foundation for safety and performance, and this standard is a step forward to support quality improvement in our business.
Previously, the aerospace engine manufacturers based their supplier quality requirements on AS9100. Each manufacturer had differing supplemental requirements and guidance originating from the need to meet regulatory, customer, industry, and business requirements not explicitly covered by AS9100 and AS9145, but with largely the same intent. The AS13100 standard sets out to create a common set of supplemental requirements and detailed guidance to improve understanding, efficiency, and performance, thus raising the bar in these key areas and ensuring clarity of expectations. The primary goal of AS13100 is to remove unique customer-supplier requirements and to include consistent customer and regulatory specifications. The standard includes a flow-down of those requirements throughout the supply chain. The current standards have been integrated into AS13100 and its guidance material, except for AS13001 DPRV, which remains as a separate AS standard. To support AS13100, reference manuals will be made available to provide deeper guidance for specific requirements. SAE International will also provide an AS13100 requirements course available globally. AS13100 is a major step in a long-term harmonization process. It represents a common standard that will be deployed and flowed down the supply chain along with the customer interface documents for each engine manufacturer.
Thinking about collaboration and this new global standard, AS13100, and the role of AESQ in our industry. Why do we need that standard? Well, as the industry has focused on quality, and all of our peers in the industry have developed their own quality programs, that can be enormously confusing for suppliers who are looking into 6, 8, 10 different customers, each with a subtly different requirement. So for us to gather as an industry and say we will have one standard that we expect all of our suppliers to conform to, and for them to drive into their sub-tiers, has to be a great thing for the industry to provide absolute clarity on our quality requirements together.
AS13100 is structured into 3 chapters. In the first one, Chapter A, we have aligned and harmonized our requirements alongside those of AS9100. In Chapter B, we have defined supplemental requirements based on AS9145, APQP, PPAP. Finally, Chapter C includes many of the requirements that were in previous standard AS13004, which is mainly PFMEA and process control.
Let's take a look at some of the key sections of the standard. AS13100 recognizes that not all requirements are relevant to all organizations. This one-size-fits-all approach of industry standards has produced a lot of frustration across the supply chain, and some would argue that it caused unnecessary additional costs. One of the new areas for the AESQ has been the harmonization of requirements for design-responsible organizations. These requirements recognize that the key to success is through the deployment of Advanced Product Quality Planning, APQP, using cross-functional teamwork. Key design processes with supplementary requirements are design reviews, design risk assessment, design to prevent foreign object debris, FOD, conducting design reviews, design for X, design for end of life, and design changes. Details on how these processes are affected by the new requirements can be found in SAE's full AS13100 requirements course.
Design and development is an area that has been seen more as in-house for each OEM. Historically, there has not been much collaboration or standardization of procedures, tools, or terminology. We have now been very fortunate to get subject matter experts from all of the member companies to work together, and we found that there is great appetite to share best practice and agree on the best way forward for all. We have created a shared understanding, looking for the similarities rather than the differences. And finding the similarities and the common structure, this will enable engineers to focus on making better and safer products without getting entangled in various formats, etc., especially for design suppliers like us working with several different OEMs. The result of the work is an initial set of common requirements, a great starting point for common alignment when designing products.
Across the customer base within aerospace, the use of Advanced Product Quality Planning and Production Part Approval Process, PPAP, is becoming the required standard for engineering change management, i.e., new product introduction, work transfers, and method change. The AS13100 APQP and PPAP timing plan promotes collaboration. Customers, suppliers, and all those involved from the various organizational functions simultaneously completing the right activities at the right time. PPAP provides a robust method for confirming that the product and process is ready for production. This is achieved through evidence that the engineering activities adhere to the correct standards and to the performance of the process, including both the quality and delivery. When APQP is done well, PPAP validates that objectively, part by part. The main benefits of APQP and PPAP are improved collaboration and communication, improved risk management, reduced costs, less rework and waste, and meeting customer wants and needs. While APQP and PPAP originate from the automotive industry, AS13100 provides a custom-made standard and foundational practices specifically developed for the aerospace supply chain application.
We've built in it not only a clear set of requirements in addition to 9145, which I might add are very few, but the most important thing about it is it's allowed us as a community to come together, understand what the differences we've been driving into our supply chain and commonize those. And that commonization is what's going to help our supply chain.
For a standard to be successful, organizations need to understand how to enact the standard as well as they comprehend its meaning for compliance.
The other piece we've done is thought hard about what will help make this work within the aerospace supply chain. What are the specific things that will benefit, enable this, and make it successful? That's the other advantage we have with AS13100 APQP PPAP. We've thought hard about what will help this work within the supply chain. Customers, suppliers, sub-tier.
One of the key outputs of the APQP process is the Production Control Plan. This defines the most appropriate methods for controlling the production process to ensure that we produce only conforming parts. Process controls should enable the organization to maintain the capability of the production process following the successful introduction of APQP and to build on it to continually improve the process capability. The more capable the process, the less chance of producing defects, which results in reduced cost and more reliable deliveries. AS13100 focuses on the importance of establishing a stable process and understanding the causes of process variation. The purpose of any successful process control strategy is to identify process changes that allow for taking action to avoid the creation of defects. It's a key part of a defect prevention strategy. The default inspection requirement in the aero engine supply chain is 100% inspection of all product characteristics. However, alternative inspection frequency plans may be approved if the organization can demonstrate process stability and process capability above the customer's defined minimum capability threshold. It's critical to the success of these requirements that the organization has developed a high level of competence in the understanding of process variation measurement and improvement. This ensures that the requirements are effectively implemented. AS13100 also includes requirements aimed at preventing defects, such as failure mode and effects analysis.
Of all the defect prevention tools, FMEA is by far the most powerful, if it's done correctly. In 2017, we published AS13004, which described the requirements for process, FMEA, and production control plan. The requirements were very prescriptive, as they were based on learning we'd had from our own organizations, plus those of the automotive industry. Organizations in the first few years have started to report significant step change in performance, with many reporting 0 defects at product launch, and also that the time taken for product introduction had significantly reduced, in some cases by up to 50%. This has been because there's far fewer product and process redesigns required as a result of applying FMEA. With 13100, we have also added Design FMEA into the suite of tools, and these are also supported by Reference Manual 13004.
Measurement System Analysis, MSA, is also included in AS13100. MSA is a term used to describe tests that quantify errors in a measurement system. Throughout history, it's been well established that measurement is key to quality. As Lord Kelvin said in 1883, when you can measure what you are speaking about and express it in numbers, you know something about it. But when you cannot measure it, when you cannot express it in numbers, your knowledge is of a meager and unsatisfactory kind. Working toward Lord Kelvin's concepts, MSA quantifies the size and type of measurement errors through simple tests. When the error is understood, you can judge if the measurement system is fit for purpose. In short, by testing the measurement system, you develop trust that the system reports the reality. AS13100 contains details of the types of tests and acceptance limits to achieve. It also includes specifics on when to conduct measurement system analysis, which depends on the types of characteristics being measured and the criticality of the characteristic, i.e., critical, major, and minor. This is set out in a simple table in the standard. While this seems like a costly exercise, it's important because it's a regulatory requirement built into the AS9100 and now AS13100 quality standards, and because MSA is a cornerstone of quality required by the aerospace industry. As Lord Kelvin indicated, if you cannot measure it, you cannot control it. AS13100 includes requirements for the organization to manage human factors. Human factors is about studying human behavior and understanding what affects the performance and limitations of all employees working on products, services, and processes. The goal is to be safe and efficient, easy to use, to learn, and to support, pleasant to use, and easy to design and manufacture. Typical conditions that can negatively influence human performance include lack of knowledge, distraction, fatigue, stress, pressure, and lack of resources, among others. For operations that rely on human skills, such as manual assembly operations or visual inspection, then managing these risk factors is critical to the success of the process.
We realized early on that we needed to focus on the human elements. There are 5 key takeaways. Number 1, senior leadership commitment to managing human factors as part of the quality and safety policy. 2, train all employees in human factors to improve understanding, engagement, and awareness. 3, encourage our open reporting culture where people can admit to mistakes without fear of retribution. 4, implement improvement plans to address risks. And finally, have trained human factor investigators to help identify root cause and implement robust corrective actions.
Across the aerospace industry, the quality audit is seen as a key activity to both ensure compliance to processes and procedures and to identify areas for improvement. The internal auditing of processes, procedures, and products are formal requirements of regulators, industry certification schemes, and customers. Some organizations can be overwhelmed by the number of external audits they must support and conduct themselves, and they feel this duplication of audit activity often adds little value. However, it's also true that these audits continue to find evidence of non-compliance, which makes it hard to justify reducing their number.
It is true that many suppliers, us included, believe that as an industry we carry out far too many audits. So how do we change that? Regulators and customers are starting to use more of a risk-based approach auditing. Therefore, organizations that can demonstrate a rigorous internal audit program and good performance may, as a result, be subjected to fewer external audits. For this to happen, we must have clear standards for quality audit across the supply chain and be able to provide evidence of the results and the effectiveness to the customer and regulators. That was what we set out to do in 13100.
AS 13100 outlines 4 audit types for the organization to use. The quality system audit includes all quality management system processes to verify compliance to AS 9100 and AS 13100, as well as to customer-specific requirements. The production process audit is designed to evaluate the effectiveness and efficiency of each step of the manufacturing process and to ensure that it's capable of producing conforming parts. The product audit is used to independently verify conformance to design requirements. It ensures that the production process verification processes remain accurate and stable. For special processes, such as heat treatment or welding, the organization shall conduct audits to verify that the processes are compliant.
When we developed the requirements, our audit approach was heavily influenced by the automotive standard TS 16949. We liked the different focus on system, process, and product. In practice, these audits may be integrated into one single audit event to reduce the impact on the business. We would expect that our customers' auditing approach will be changed as it becomes confident in the audit activity, and the result is demonstrated through the annual audit report. This may initially lead to audits that are much narrower in scope, in some cases an audit of the audit process only, perhaps. It may also lead to gaining enough confidence to not require an audit at all. That would be our goal.
AS 13100 also provides requirements for sub-tier management. Over the past 20 years, supply chains have become longer and more complex. It's now a truly global supply chain and one that provides up to 75% of the parts that go into an aero engine. This supply chain is comprised of a wide range of business, from large multi-billion-dollar international businesses to small family-run businesses of fewer than 100 people. We know that a supply chain is only as strong as its weakest link. Regardless of the business type, customers and regulators expect their requirements to flow seamlessly from top to bottom. One of the key functions of AS 13100 is to capture the regulatory and customer requirements that must be flowed down to the supply chain in a concise and standardized manner. Every supplier must have the proven capability to meet these requirements and the ability to support the needs of the customer in terms of quality, delivery, and cost.
We know that in the aero engine supply chain, we need suppliers that can manage a high level of complexity when it comes to regulatory, industry, and customer requirements. It is more important than ever that we only work with suppliers that have the capability to meet these requirements and also the desire to work with us to achieve our goal of 0 defects. We must all take responsibility for managing our part of the supply chain and work in a collaborative way to get the best results for all. Our customers have high expectations on safety, quality, delivery, and cost performance, as should we. And we will all need to take additional ownership and accountability, not only of what we directly own, but what we indirectly own as well. Specifically talking about sub-tiers at every level. AS 13100 and Reference Manual RM 13007 provides a great framework to explain how to manage these challenges and opportunities throughout the supply chain.
One of the first topics that the AESQ worked on was problem solving. When things go wrong, customers and regulators expect the industry to react quickly and robustly to protect the customer from the impact of non-conformance and to ensure that we quickly get to the real root cause and implement corrective actions so the problem cannot recur. Previously, aero engine manufacturers all had different approaches and templates that they required suppliers to use, each with similar intent but a different language. Since the publication of AS13000, engine manufacturers have seen the benefit of this harmonization, especially when dealing with issues deep in the supply chain. The standardization of approach and reporting means it's been much easier to follow the thread of the investigation. The AESQ has also listened to feedback from suppliers who said the prescriptive nature of the AD template within AS13000 was sometimes restrictive and that a more flexible approach would be beneficial. The final highlight of AS13100 that we'll focus on represents a major change for the aero engine supply chain. Moving away from customer-unique specific requirements to a single harmonized standard has meant creating a common language for quality among the engine manufacturers. This means that we must take the time to fully explain the intent of each element to those who must deploy them. There are 2 specific training courses required by AS13100 to understand the intent of the standard and its effective deployment. One is on-demand training for the AS13100 requirements available through SAE International. The other is a Quality Foundations training that focuses on the design and production processes of the aero engine supply chain and includes detailed training, insights, and discussion on topics including advanced product quality planning and production part approval process, process control, product safety, supply chain management, and human factors.
The training is planned to be interactive while introducing and discussing some of the quality tools, techniques, and expectations. The suppliers appreciate the ability to engage directly with the customer and to hear how other suppliers are navigating through various challenges. Although the training is aimed at suppliers' manufacturing engineering team members, along with quality leaders, there have been many other functions attending as well, including program management, sales, executive leadership, and operations.
AS13100 sets out to create a single harmonized set of requirements that are aligned to AS9100 and AS9145. In doing this, it will significantly reduce the number of customer-specific requirements and help to create a common language for quality.
The AESQ mission becomes reality with the AS13100 standard. It is our common set of quality requirements which will be cascaded contractually to the supply chain by all AESQ members. Our vision was to eliminate all various OEM supplier handbooks, including our MTU-specific supplier guidelines.
The main benefits I see is really to optimize our organization and interface to improve our quality level and all the performance of the supply chain. Today, improving the quality is mandatory for our business. First, because the quality is the last step before the safety, and second, because the poor quality always impacts deliveries and our costs. The level of technology and complexity of our products increased dramatically during this last decade. In the same time, the development cycles reduced and the expectation of our customer increased quite a lot as well. We have no choice but reaching zero defect from day one and reduce our costs. So our philosophy is simple. The more complex the product is, the more straightforward the requirements shall be. That's why AS13100 is a real game changer.
I think this collaboration that we're on our way to do is going to really affect the way we work jointly and get APQP and, for example, the design FMEA as a standard way of working for everyone. And when you think about that and look how it logically worked into the PPAP activities, that everyone used the same way and same process of using the PPAP and, for example, the process FMEA. How we connect those dots and we make it as a natural way of working, in the qualifications and maturity of our products and processes, that is going to be phenomenal.
In developing AS13100 and its reference manuals, we have engaged with over 100 subject matter experts from across the member companies to capture what we consider to be the current industry best practice. Once deployed, it has the potential to reduce the number of unique customer requirements by over 60%. Now, there's more that we can do, but this standard represents a major step forward in our harmonization goal, but also to create a common language for quality as part of our zero defect strategy. Although developed by the Aero Engine Supplier Quality Group, we believe that this standard can be of benefit to any organization in any industry.
AS 13100 is about collaboration, quality, and safety. It's bringing the industry together to reach the ultimate goal of every aerospace company, zero defects. It's a safe flight home to see family. It's a business meeting in a different country. It's exploring a new city. The SAE AS13100 requirements course will dive much deeper into the concepts discussed here and will provide the necessary training for your company to successfully adopt the AS13100 standard. For more information about the AS13100 requirements course, visit discover.sae.org/AS13100 or contact Corporate Learning Solutions at corplearn@sae.org or call 724-772-8529.